All right, guys. So this video is for the 5.2 lab. So if you were gone on Wednesday, February 23rd, or the 24th, which is today, this video is going to kind of walk you through the lab, give you the results that you need, and you should be able to answer the question. So first thing with this lab is a little bit different. We didn't have a data table in there. So all you needed to copy down in your pre-lab stuff is you need to get your purpose statement still. Why are we doing this lab? What are we trying to accomplish? And then our materials, because when we did this lab, it's pretty important to understand which gases are we trying to create and what materials do we need to make those gases. And it's kind of easy to get kind of mixed up when you see, if you're relatively new and you see, okay, HCl versus H2O2, they both start with, H, and you got hydrogen peroxide and hydrochloric acid. You just don't want to get them mixed up. Okay. So part one, we want to create oxygen gas. And what it wants us to do is we have manganese dioxide. Okay. And you can kind of see that there in that little test tube, little black powder. And it wants us to add hydrogen peroxide. Okay. So our H2O2. Okay, and this is going to create a reaction, and it's going to, hopefully, we're going to start to produce oxygen gas. So what we did, my candle here. Okay. We want to create some oxygen gas in our test tube, and we're going to see if we can test it, and then we're going to want to actually try and prove that it was oxygen gas. Okay, so first thing I'm going to do is take my peroxide. Okay, I'm going to add it to our manganese dioxide, and we can start to see definitely fizzing, bubbling, things like that. Anytime in science when you see that bubbling, fizzing, we know we're producing some sort of gas. That's what's creating the bubbles. Okay, and I can start to feel the pressure in. Start to feel the pressure in here. Let's see if I can get it to hold it in a way that you can actually see it. I can start to feel the pressure build up in here. Okay, so now for this first part of the test, it says we're going to light our wood splint, let it burn for a second. We want to get a good ember going. Okay, so once we do that, then I'm going to take my thumb off, and here's was our test. Wow. Oh, you missed it. Dang it. That was bad, Mr. Harthen. Here we go. And it relights. Okay, so we can see how many times we can do that. Okay, so that's kind of an out of the ordinary thing, right? So we don't usually blow something out and then have it relight like that. Okay, so we want to think about when we answer those analysis questions, what's going on here? What do we need in order to have fire? What do we need to have? Okay, what three things do we need to have? And then what is being collected in this test tube? Okay, whoa, one more time. Okay, so that one's pretty cool. So our wood splints out. Keep that there. So now the next one is for hydrogen. Okay, so hydrogen asks us, we need a little piece of zinc, which we have in there. I don't know if you can see that. Okay, and then hydrochloric acid again. So this is kind of a medium strength hydrochloric acid. It's a 1 molar solution. So we're going to get all that in there. And this time it's a little bit different. So what we're going to do is I'm going to put the acid in the test tube, and then I'm going to try and collect it with the other test tube. Okay. So now, while this is collecting, let's talk a little bit about those synthesis questions or the analysis questions for part one. So the three things that we need to have a fire is we need to have some sort of fuel, we need to have oxygen present, we need to have heat. So when we look at our wood, the wood was what actually was burning. Okay, so that's actually our fuel. Okay, and then that glowing ember is very hot, right? So that's what's actually producing the heat. Now, there is oxygen in our atmosphere, but once you blow that candle out, there's not enough oxygen to fuel or help allow that reaction to take place at a fast enough rate to keep that going as a normal fire. Okay, but when we put it into the test tube, now we had this abundance of oxygen that really sped up that reaction and allowed heat to ignite that wood splint again. Okay, so that's how that oxygen one works. So now we want to think about that. Okay, we saw just kind of reignited. The wood is still what was burning, so that's going to be a little bit different than our hydrogen test here. Again, you can see we got a lot of bubbles, so we know we're getting some sort of gas production. Okay. And with this one, you can see as you read through the procedures, a little bit different, right? So we're collecting the gas in the test tube on the top because hydrogen's very, very light. That's going to help us with some synthesis questions later on. So hopefully what's happening is as we produce these bubbles, that gas is going to rise and it's going to collect up in this test tube here. Now, with the wood splint, instead of blowing it out this time, what we're going to do is we're going to leave it lit, super lit. And we're going to put it at the bottom of this top test tube when we take it off. Okay, so we'll give it another second. Just want to make sure we got a good reaction going on here. Okay, I think that should be good. Okay, so let's see if we can do our test. Oh boy. Okay, we got it ignited and wowee! Okay, so obviously a different reaction there. Okay, we're producing hydrogen gas. So one of the questions says, how is this one different? What did we see that was different when we had the splint still lit? But yeah, we got a very different, a little bit more, a little bit stronger reaction, right? A little bit more explosive. So we want to think about that, and then we also want to think about that with our synthesis question. So it asks you to look up the Hindenburg, give us a brief explanation of what that is. And so when I mean brief, I mean like 2 to 3 sentences. It can be very short. Key is what was it filled with, and then how does that connect to our lab? Then it talks a little bit about blimps today. Not very many blimps floating around, and there's kind of a reason why. And then the last question talks about, okay, what are they filled with now and why? Why do we use that type of gas rather than hydrogen? And what makes that gas so stable? So we want to think about everything we've learned about the periodic table. What group are they in? What family are they in? So think about those things. What do we know about their valence electrons? Okay. If you have questions, let me know.